Good day, viewers. My name is Ejimele Maxwell. I am a new YouTuber and I'm here to teach from JS1 to JS3 mathematics. Before I go on, let me introduce my younger brother. This is Maxwell the Mathematician. Like, subscribe, and share, and enjoy the video. Thank you for the comment on it. And I will go on to introduce Ejimele Loretta, my younger sister.
I am his younger sister. Like and subscribe and comment.
Meet my dad's sister, Ejimele Rejoice. And meet my dad, Dr. P. Ejimele.
Enjoy the class.
Now I'll be teaching JS1. I'll be teaching them mathematics, and the topic I'll be teaching them is number system. There are 9 types of number system, but I can't mention them all. But the one we'll go for is number 1, base 2 or binary system, which consists of 0 and 1. Base 2 binary or binary system cannot reach 2. That is why it's called base 2. Base 3 is the same thing. It cannot reach 3. Base 4 the same thing. Base 5 the same thing. And it goes on and on to base 10, which are known as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we will enter the expand notation. We are expanding 3, 5, 6, base 8 to base 10. We are expanding it. So if you are expanding from base 8, if you are expanding, you have to go to base 10. But this one is expanding. We are not solving, just only expansion. So it will be 3 times the base that we are under, that is 8, plus 5 times 8 again, plus 6 times 8. So if you move from here to here, every 8 in before the plus will carry a number. They'll carry an index. From the beginning is 0, the next is 1, and the last is 2. It is 0, 1. So this is the expanding notation, which is 3 times 8 raised to the power 2, plus 5 times 8 raised to the power 1, and plus 6 times 8 raised to the power 0. That is the expanding notation of 356 base 8. This one is 2135 base 6. We're expanding it like how we did this one. So this one will be, which base is this? That is base 6. So this is 2 times, what is this? 6 plus 1 times 6 plus 3 times 6 plus 5 times 6. So it will carry an index like how this one carries. So we start from the end. If you want to give an index, you don't start from the beginning. Because if you start from the beginning, your answer will be wrong if you change it to base 10. So that is why we start from the end. So it's 0 we start with, then followed by 1, followed by 2, followed by 3. We put all this index on this 6 because it is base 6 where the number was under. So that is why we put all those indices there. So the next one is 10321 base 4. 10321 base 4. It is not called 10,321 base 4 because this is not base 10. Assuming it's base 10, it will be called 10,321. Because our base 10, when we are counting 1, 2, 3, 4, 5, 6, 7, 8, 9, we don't add 10 because we know it's usual. So we go, since it's base 4, we go 1 times 4, this is the 1 here, plus 0 times 4, the 0 here, plus 3 times 4, that's the 3 there. This is the 2, so we add plus 2 times 1, plus 4, then plus, what is the last one here? This is 1. So it is 1 times 4. So where do we start from? Is it the beginning or the end? We start from the end. So you start with 0 on every 4. On every 4, that is when you put the indices. So this 4 carry 0, this other 4 carry 1, this other 4 carry 2, this other 4 carry 3, and the last one carry 4. This is the expand notation. This step will take you into expanding from a base to base 10. This expand notation is the beginning of expanding from base 2 to base 9. We expand it to base 10. So the next subtopic we're going into is converting base 10 to base 2. This one is from base 10 to base 2. So the way we did this one is going to be different because this one is from the base 10 to base 2. So solution number 1 is 45 raised to 45 base 10. So it is 45 base 10 equals that. We will not do it this way because we are not going from base 2 to base 10. We are going from base 10 to base 2. So we will draw a single table. Then we'll put this our 45 here. We put our 45 here. Then we are converting the number, this 45 base 10 to base 2. So what the number we're going to use to divide this 45 is 2. Reason is because we are converting to base 2. Assuming it's converted to base 3, this 2 is not going to be there, it will be base 3. Assuming it's base 4, it will be base 4. But our instruction was to convert numbers in base 10 to base 2. So this is the number here is going to be base 2. Now is our division time. Now let me tell you before I go on. Any remainder you get, you write your remainder here. Your remainder is useful because that is what you use to get your answer. So if you don't write your remainder, just know what you've done is just for waste. And there must not be point. There's not like 11.5 when you're dividing. No, it is 11 remainder 1. That is if you are dividing by 2. So let's divide. 44 divided by 2. We know it's 2, right? 2. 5 divided by 2. That is 2.5. But we must not have a point. So it will be, what is the number that can go? That is 2 times 2, that is 4. And it's remain 1. So it will be 22. Then put your remainder. Your 1 is there. Let's check if you are correct. So it will be 22 times 2. Our answer is 44 plus our remainder. It gave us 45. You see we are correct. Let's move on. 22 in 2. We know it as 11. We have no remainder, so it will be remainder 0. It is remainder 0 because 22 in 2. 2 in 22 is 11 without no remainder. So that is why beside the remainder we wrote 0. Now we move on. 11 divided by 2. Let's take it step by step. Step by step. 2 times 2, 4. Is 3 remaining. 11 minus 4, that is 7. Is 3 remaining more. 2 times 3, 6. Is 3 remaining. 2 times 4, 8. Is 3 remaining. 2 times 5, 10. 2 times 6, 12. 12 is greater than this, so 6 is not going to be the answer. What is the number before 6? 5. So 2 times 5 is what? 10. 2 times 5 is 10. So 10 divided by 2, 5. 5 times 2 is 10. 11 minus 10 is what? 1. So our remainder is 1. Let's check if we are correct. 5 times 2 equals to 10 plus 1 is 11. So let's keep on dividing. 5 in 2. 2 in 5 rather. That is 2 remainder 1. How is it 2 remainder 1? 2 times 2 is 4. So 5 minus 4 is 1. So that will be 2 remainder 1. We will go on to divide. Until this side before the remainder becomes 0. We will keep on dividing until it becomes 0. Because 0 is what we are supposed to get by this side. So 2 divided by 2. 2 divided by 2 is 1. 1. How many remainder is there? 0. Because if you times 2 by 2 times 1, it will give you 2 without remainder. So this will be 0. Then we go on to divide. 2 divided by 1 is impossible to give us 0.5. So that it is 0. So 2 times 0 is 0 plus 1 is remainder 1. So as long as this side is 0, we are done with dividing. So to get your answer, from the end of this place, you start from the end going up to the beginning. Let me repeat that again. You start from the end where the 0 is, the remainder. You start from there, then you go up to the beginning. But if you start from this one that is at the beginning here to come down, alternatively your answer will be wrong. So that's why we start from up there. So this is 1. Again, this is 1. The next number after that one is 0. Next number is 1. Next number is 1. Next number again 0, and last number is 1. So your answer is 101101. That is equals to 45. This 45 times is equals to 101101. 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. So let's see if we are correct. 1, 0, 1, 1, 0, 1. We are correct. So we start from the end. As I said earlier, when you are expanding, you start from the end. You start from the end of that base. If that base is 2, it will be 6 times 2. That is 2. 2 be here. Assuming this place is 2, 2 be here. So you start from 2. So this place, this is the end. So we start with the indices of these 2 will be 0. This one will be 1. This one will be 2. This one will be 3. This one will be 4. And this one will be 5. Now, this is 1 times 2 raised to the power 5. 2 raised to the power 5 is 2 in 5 places. You multiply 2 times 2 times 2 times 2 times 2. That is 2 raised to the power 5. So 2 in 5 places is 2 raised to the power 5 in short form. So it will be equals to 1 times 2 times 2 times 2 times 2 times 2. How many 2 do we have here? You have 1, 2, 3, 4, 5. So this is equal to this. Plus 0 times how many 4? How many are we going to do for this 2 raised to the power 4? We're going to do 4. So it will be 2 times 2 times 2 times 2 plus 1 times, what is this? 2 raised to the power 3. So how many 2 are we supposed to have? We have to have 3. So it will be 2 times 2 times 2 plus 1 times these 2. How many 2 are we supposed to have in 2 raised to the power 2? It is 2. So it will be 2 times 2. Then plus 0 times 2. 0 times, this is 2 raised to the power 1. So we have to have only 1, 2, 1. So we have to have only 1, 2. So it will be 2 plus 1 times. Now, anywhere you see anything raised to the power 0, it is equals to 1. If it's king raised to the power 0, the answer is 1. So this 2 raised to the power 0 is equal to 1. 3, it goes to everything in the world. Anything raised to the power 0 in this world, it is equal to 1. It is not the same number. But anything raised to the power 1 is that same number. So we move on. So this is it here. 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. Two of us, let's add it here, 32. This is 1 times 2 plus 0 times 2 times anything ahead is 2. 2 times 2 times 2 times 2. That is 2 raised to the power 4. But it is multiplied by 4. It is multiplied by 0. It is 0 times 2 times 0 times 2 times 2 times 2 times 2 is equal to 0. So the answer of this 0 times 2 times 2 times 2 times 2 is equal to 0. Why is it 0? Because 0 times any number, even though it's 159.1 million, it is still 0 as long as 0 is the multiplicator. So it is 0 plus, we've done this one, now we're going into this one. 1 times 2, 2 times 2, 4 times 2 again, 8. So we're adding 8 here, plus 1 times 2, 2 times 2, 4. 4 plus, what did I say? I said something earlier. Anything multiplied by 0 is equal to 0. Even though it's times 1 million naira, it is equal to 0. Plus 1 times 1 is 1. Anything multiplied by 1 is always 1. So let's add it. 32 plus 8, you have 40. 40 plus 4, 44 plus 1, 45. What was our beginning? 45. You see, we are getting to the same answer. So as long as you know that this is, and you check it that it is equivalent, just know that your answer is correct. You are correct in what you are doing. So then I don't have time to explain all the remaining two examples there. So I gave you as class 1. Convert 184 base 10 and 35 base 10 to a number in base 2, as I taught you using 45 base 10. Then you can submit your solution to this email. You can use your parents' email if you don't have one. Submit it to this email provided here. Then in the next class, I'll be teaching JS1, converting numbers in other bases to base 10, and converting numbers from one base to other bases. So let my brother come and analyze things. I hope you enjoyed the video or class. This is the email. I can submit the assignments to, and it's not hard. It's so simple. As he said, you can in the next class doing activities are here, and you can also subscribe, share, and subscribe to this video, because we'll be dropping videos before you know. You'll be dropping videos before you know it, for your children to learn something from Max the mathematician.